So welcome to all our visitors online. This is the fourth of in our series of online panel discussions, broadly considering themes that have been arising from the COP26 climate change meeting that was held in Glasgow last month. And we've arrived today at the topic of the ways in which nature may contribute to mitigating effects of climate change. And the broad title of the session you'll see here is Safeguarding Ecosystems, Protecting Natural Habitats and Keeping Carbon Out of the Atmosphere. So my name is David Burslem. I'm in the School of Biological Sciences here at the University of Aberdeen, and I also serve as the Interim Director for the Environment and Biodiversity Challenge Area. The format today, as with the previous sessions, is that we have a number of presentations from our panel members, and that will be followed by approximately 30 minutes of question and answer session. So we're hoping that you will have some questions arising from the discussion that we're going to have, and that you'll put them in the chat. And if you the questions will be prioritized based on the number of likes, and so if you are would like to support the idea of a particular question, please like it, and we'll take it in that rank order. So this is a very large topic. You can see it's a long title, and as a result we have a fairly large panel who will address the first half of the session. And that is because, of course, it's a really important topic, and we know that climate change is one of the major factors that's contributing to the crisis for biodiversity globally, and that also nature is very important for helping to offset climate change. So there's two senses in which nature interacts with climate change. And although the context here is COP26, obviously, this comes on the back of, so the COP initiative comes on the back of a large range of other conservation initiatives that have been negotiated between governments and involving various NGOs and even the private sector. This is just a small list of some of the initiatives that have been in existence over the last 10 years. Each of them involves targets at a high level, in some cases agreed by governments, in other cases being promoted by individual NGOs or the private sector. Three of them you can see there at the bottom indicate the intention to plant a trillion trees globally. So the policy context within which the COP meeting was placed was itself already very complex, and one of the major achievements of COP was an intention that governments arrived at to protect forests into the future. So about 130 countries supported what's known as the Declaration on Forests and Land Use that was signed off at COP, and you can see there the green parts of the planet highlighting those areas where the leaders agreed to the principles outlined in this declaration. And this comes on the back of the recognition that deforestation has proceeded very rapidly, has been a serious problem, and that there needs to be a commitment to work to both halt deforestation and actually then to reverse it. And the reversal part there is largely the context for some of the talks we're going to hear this morning around experts who work on the use of trees for mitigating greenhouse gas emissions and the extent to which forests and other nature-based solutions might promote that. So what do we know about the ways in which we ought to use natural ecosystems to mitigate climate change? Well, there's quite a lot of science behind the idea that we should focus on two concepts in particular: connectivity and space. So natural areas should in principle be well connected, and then they should also be rich in species, and these two things are themselves connected. So richer communities of more greater biodiversity arises in part from greater connectivity. We know that from various sources of evidence. There are experiments at large scales that have been conducted that demonstrate these principles. We can directly observe the movements of plants and the movements of pollen and seeds in relation to plants, and demonstrate the benefits of connectivity. And then these can be placed at larger spatial scales using various modeling techniques. And this body of evidence tells us that connectivity is important because it allows species to move as environments change, and it promotes the maintenance of genetic diversity within species. And it also highlights the benefits of species diversity in terms of the increased resilience to climate shocks, and the fact that different species react differently. They're complementary in the ways they respond, and therefore more species in principle enhances resilience. So those are two of the key things that we have learned from this body of evidence. In addition to that, we focus in particular on first protecting natural areas and biodiversity before we intervene, and there's a really important principle there, that we need to protect what we have before we think about things like restoration, important as that is. When it turns to restoration, we have to focus on the spatial context. So spatial planning is really important, and that really draws attention to the importance of connectivity. There's going to be a discussion this morning around the role of tree planting and natural regeneration. Tree planting is an intensive mechanism for restoring forests, and natural regeneration is a more passive approach. Intensive approaches, of course, are more expensive, and therefore there potentially is a trade-off in terms of the total area we might consider restoring using these different approaches, and that's very much part of our planning. And then it's really important that as we progress these ideas, we need to do so in partnership with local communities. And we're very fortunate here in Scotland, and even more so in the northeast of Scotland, because we have some really flagship projects, some of which you may have known about. Those listed on the top bullet point there: Trees for Life, Cairngorms Connect, Carriffram Wildwood, are really large scale, landscape scale approaches to restoration, all based in different parts of Scotland. Here in Aberdeen, we have a project connecting the green spaces of our own city. So even really locally, there's a commitment to understanding how the importance of connectivity and the roles of these green spaces in people's lives. And there's an expansion of community woodlands as well, even in existing rural areas, and that extends to partnerships between communities, landowners, and institutions such as the D-Side Partnership. So although there has been this focus, really strong focus on initiatives at a very high level between governments and involving the United Nations, and very much the outcomes of the COP process, we can all get involved in this through these very local projects. So now I'm going to turn to my colleagues. I'm going to stop sharing my slides and begin with an introduction to, or just turning over to my colleague here at Aberdeen, Pete Smith, who's going to talk about nature-based solutions to tackle climate change.
Thanks very much, David. So we have a range of options for removing greenhouse gases from the atmosphere. So obviously we need to reduce our fossil fuel emissions and reduce emissions across all sectors. But there are some emissions that are going to be very difficult to remove, maybe due to aviation. If we're still going to continue flying in the future, that's very difficult to decarbonise. And particularly agriculture, which emits greenhouse gases, nitrous oxide and methane, which are very difficult to abate. That leaves us with the problem of how do we mop up those remaining greenhouse gas emissions that we can't reach through traditional mitigation technologies. And that's where we start to look at greenhouse gas removal. This is something we put together, this little graph for the emissions gap report in 2017, which just basically characterises the greenhouse gas removal technologies as those technologically based. So things like direct air capture, which uses a sorbent to cap CO2 from the ambient atmosphere, and it's then scrubbed from the solvent and pumped back underground. So this is an example of a technological approach. But the ones I'm going to focus on today are the natural solutions, natural climate solutions, such as afforestation, reforestation, the use of biochar, the use of soil carbon sequestration through changing our land management practices. And it's more than just trees, as I hope I've shown on this. We've also got the opportunity to use coastal wetlands and peatlands to restore those and to protect those. And they have a great carbon sequestration potential and emission reduction potential, as well as blue carbon in the coastal and off the coastal shelf and in marine systems. The advantage of these natural systems is that we know how to do them and they're less costly, but they are more vulnerable to reversal. So the carbon sinks can be, for example, if we plant a forest, it can be wiped out by pest and disease. It can be subject to wildfires, so we can lose that carbon. The technological solutions are more costly and there are greater R&D needs, but when we remove CO2 from the atmosphere using these technologies, it tends to be more long-lived. But going back to the natural systems, there's actually a very large, significant mitigation potential. So in a paper in 2017, Griscom and colleagues just estimated the total potential that's available in the land. So these are land-based natural climate solutions. And these numbers across the top is the mitigation potential in gigatons or petagrams of CO2 equivalents per year. And it's really quite large for some of these options. So we've got options in forestry, we've got options in agriculture and grasslands, and we've got options in our wetlands, including coastal systems. Now, the technical potential is maybe up to 20, 25 or 30% of all our greenhouse gas emissions, but we're not going to be able to realise that total technical potential. But we could realise an economic potential that's somewhat smaller than that, but still maybe about 10% of the greenhouse gas emissions. And that's the amount that we need to remove those difficult to abate greenhouse gas emissions that will remain in the system in 2050. And it's these natural climate solutions that allow us to get to net zero, because we still have some remaining emissions going into the atmosphere, and we will use these carbon sinks to counterbalance those emissions and get us to net zero. So I'll just finish by saying that changing consumption patterns, the individual choices that we make, if we choose to eat less meat and dairy and to reduce waste, this saves land that can then be used for nature-based solutions. Some nature-based solutions don't use land. For example, soil carbon sequestration can be used on land that is still producing food, but we're going to need to put aside some land while still feeding more people. So because eating meat and dairy uses about 10 to 100 times more land than plant-based products, eating less meat and dairy can create that headspace for nature-based solutions. The second thing to note is that the land can't do it all. There's not enough land to soak up all the emissions from all other sectors. So what we have to do is we need immediate and aggressive action to reduce greenhouse gas emissions in all sectors of the economy. Nature-based solutions aren't a substitute for aggressive and immediate action. We can only use them at the end of the pipe to really mop up those remaining emissions. So most land-based emissions can be implemented in a way that help biodiversity, help the Sustainable Development Goals, and help local communities. So if those natural climate solutions are implemented in that way, they could be considered as nature-based solutions. But if implemented poorly, they could harm biodiversity and ecosystem services. So it's really not what we do, it's the way that we do it, and we have to really implement them carefully, using techniques that enhance biodiversity and planned and involve the full consent and active participation of Indigenous and local communities. But if implemented carefully, nature-based solutions are good for biodiversity, good for people, and they can be good for both climate change, mitigation and adaptation. So that's a brief overview. I'll leave it there, and I think I'm handing over to Ruth now. You're muted, David.
Whilst that transition is taking place, I'll just briefly introduce Ruth Mitchell, Dr. Ruth Mitchell, who is at the James Hutton Institute here in Aberdeen. And she is going to be the first of two speakers focusing on trees and forests as one component of the nature-based solutions outcome. Okay.
Hello, everybody. Thank you very much for inviting me along today. I'd just like to start by acknowledging that some of this work was done in conjunction with Stirling University. And as David said, I'm looking at tree planting, which, as Pete was suggesting, is one of the potential nature-based solutions that we're using at the moment. So the logic behind this is very simple. Trees store carbon dioxide in their biomass, and if we've got more carbon dioxide in the biomass, then there'll be less in the atmosphere, and this will reduce our climate change. And because of this, both the Scottish and the UK government have got plans to increase the amount of forestry cover with some massive tree planting programmes that they started. But although the sort of logic behind this appears quite simple, it's perhaps not quite as simple as it might first appear. And we wanted to test this assumption that tree planting results in increased carbon storage. So to do this, we utilised some long-term experiments that we've got at the James Hutton Institute. The first one, the yellow square you can see on the map there, that had birch and pine trees that were 12 years old. And the red squares had some birch trees that were 39 years old. And these are experiments that we set up where we planted these trees on open heather moorland, so the type of habitat that a lot of tree planting might be occurring on over the course of the next few years. But as Pete briefly mentioned, a lot of carbon is also stored in our soils. In fact, globally, more carbon stored in our soils than in our above ground vegetation. So when we're thinking about the impact of tree planting, we not only need to think about the amount of carbon we're storing in the above ground vegetation, but also how much we're storing in the soils. And these are the results of our youngest site. So this is the ground level, the line across here, and the brown parts are the amount of carbon in the soil, and the green parts the amount in the vegetation. And all our plots were open heather moorland initially, so they were similar to this bar chart here with the heather. And you can see the heather plots store an awful lot of carbon in the soil and very little in the above ground vegetation. 12 years after we'd planted them on the birch plots, we'd lost a lot of carbon from the soil and we'd gained a bit of carbon above ground in the trees. But overall, there was a net loss of the amount of carbon that we were storing. In the pine plots, we'd lost a bit of carbon from the soil, gained a bit of carbon above ground, and overall there was no net gain. Now you might say to me, that's fine, but those trees are quite young, and once the trees are bigger and they're older, they'll be storing more carbon. Well, these are the results from our slightly older plots, our 40-year-old plots. And actually they showed a very similar pattern. Above ground, there was an increase in the amount of carbon we were storing, but below ground, in all cases, we'd lost some of the carbon. And in all the cases, the best scenario was that there was no net gain in carbon. So the amount we were gaining above ground was only offsetting what we'd lost from the soil. So you might tell me that these are only experiments, and how relevant are they to the rest of Scotland? Well, as I indicated, the types of soils these experiments were set up on are the types of soils that actually occur across a lot of Scotland. And also the experimental timescales that we're talking of here of around 40 years are very similar to those sorts of timescales that we're thinking of in terms of net zero. If we want to use trees as part of the mechanism of reaching net zero by 2045 in Scotland, we've only got around 25 years. However, we do need to make clear that if you're planting your trees on mineral soils, you're much more likely to get a gain in in the amount of carbon you're storing, because you won't be losing that carbon from the soil. Obviously, we only looked at 2 tree species, and there will be differences between different tree species, and how you plant your trees will have an impact. You can see in the pictures here, there's been a lot of disturbance in these tree planting, and that will increase the amount of carbon you lose. Whereas in the methods we use to plant our trees, we had very minimal soil disturbance. So really what I just want to highlight here is that I'm challenging the assumption that tree planting will always mitigate climate change. As Pete said, it really depends exactly what you do and how you do it. You need some careful thought behind where you're planting your trees and on what soil types. So thank you very much, and I'm going to hand over to David next. So hopefully
yeah, so thank you very much, Ruth. And whilst David Coombs is coming on screen, so yeah, Professor David Coombs from the Department of Plant Sciences at Cambridge University is next, again talking about forests. Can I, before David starts, can I just encourage anyone who has questions to put them in the chat? I'm not yet seeing any, but hopefully there will be questions emerging over the next few minutes. Okay, over to you, David.
Thank you very much, David, and thanks to Pete and to Ruth for such excellent talks already. So I'm going to talk further about forests as nature-based climate solutions, and very much echoing the point that Pete made at the start, that we do rapidly need to decarbonise our economies, but there will be sectors of the economy which are hard to decarbonise, and that's where these nature-based solutions will be important. And the economists amongst us recognise that we somehow need to support these nature-based solutions financially in order to get our emissions down by 23 gigatons of CO2 globally by 2030. That's what we need to achieve to stand a good chance of staying within 1.5 degrees climate warming. To cut a long story short, these nature-based solutions could be a really important step in achieving those targets within the next decade. Avoided nature loss and not destroying forests, not destroying peatlands, creating new ways of protecting woodlands and nature as well. Both very, very important, but we're a long way from meeting those targets at the moment. One thing we can do is look to protect the vast areas of nature which are left in many parts of the world, the tropical world, such as these beautiful dry woodlands here in southern Africa. And the problem here is that these trees are being cleared to make charcoal, and the charcoal is being taken into the cities as a fuel. And you can imagine that that's not a particularly profitable business, but when livelihoods, when incomes are very low, it's still an important livelihood. So we can imagine a system whereby these forests are protected and local people benefit from protecting them. They're paid to protect them. They are given alternative livelihoods which are more prosperous for them. They're protecting local biodiversity. And something is happening in the cities so that demand for charcoal is lessened. Some cleaner fuel is used. So a sustainable development project, which is one of those win-win-wins for biodiversity, for livelihood, and also for helping the climate, is what we would hope to achieve. In the UK, it's really quite complicated in terms of tree planting, and I think Ruth has already alluded to that, and that's because we're a crowded set of countries. We're already intensively making use of our land in a variety of ways. So where are we going to put woodlands if we're going to plant more of them? We're one of the least wooded countries in Europe, and for a long time people have been calling for more woodland. This is just for a bit of fun. Here's actually Madingley Wood, owned by the University of Cambridge. We're one of the least wooded of all the counties in the UK, only 2.5% wooded. This is how the Luftwaffe saw the wood in 1942. We actually have 42,000 tiny scraps of these ancient woodlands left across the United Kingdom, kept across our landscapes because they were of value to local communities in the medieval periods for extracting timber, charcoal, and using it locally. And one of the things we really must do, as Pete mentioned in the first talk, is to protect these wonderful harbours of nature across our landscapes. And now we have an opportunity to expand around these and create new woodlands which benefit people and biodiversity, as well as acting as carbon sinks. We have a bit of a dilemma in the UK about what our priorities should be, and different people have different perspectives. I've emphasised that the value of planting woodlands or allowing natural regeneration for human well-being and for biodiversity, and it's obvious what we need to do for that, I think, and other as well as planting around these ancient woodlands and creating corridors, as David Burslem mentioned at the start. We may also want to plant around urban areas to allow people access to nature. So those are all easy wins. If we want to maximise the carbon sink, actually we need to do something rather different, and I'll come back to that in a moment. And if we want to maximise timber production, again we've got to do something different. If we want to go down the path of using our woodlands to fuel power stations, this is the Drax power station at the bottom, that would be a bad idea because these power stations would require a huge amount of wood to support them, and they're currently importing wood from overseas to do that. But if we did want to do that, that would be another dimension which we'd have to think about. And then we've got other uses of woodlands, valuable ones, flood relief and reducing pollution. And we know these non-market values have a much greater value, 12 times the value of timber production, and that needs to feed into our thinking. Well, the idea of planting new woodlands and the value for humanity has been much thought about for over 15 years, and this very influential report from 2009 set out what the benefits of planting woodlands could be for the carbon sink, drawing carbon dioxide out of the atmosphere across the UK, and essentially planting 230 square kilometres of new woodland per year from 2010, when this report was setting its targets for. It calculated that planting those new woodlands would slowly, not immediately, increase the carbon sink, so that by 2070 we were drawing down substantial amounts of CO2. But it's going to take quite a long time if we're planting woodlands to achieve those goals, and not those instantaneous goals we need to combat climate change. And we really have to take into consideration Ruth's point. Now, I've deliberately avoided putting Scotland on this map because I knew Ruth was talking about the Scottish tree situation. But here is a map of the quality of soil for agriculture across England and Wales, and you can see the blues are the really good bits for agriculture. They actually include the fenlands, which are emitting carbon dioxide close to where we live because the fens are oxidising. And also the green areas are pretty good for agriculture. As you get onto the yellows and purples, much less good for agriculture, mostly sheep and wide range land management. Where on earth do we put all those woodlands which the government's proposing? Well, in the context of England and Wales, we would need to put them on these yellow areas where we currently have sheep, and that would only be possible if we reduced our consumption of meat, as Peter said. Otherwise, we're just going to send the problem overseas by importing that meat and not helping resolve the crisis of climate change. So that's my talk. I was actually involved in this really interesting set of papers by the British Ecological Society last year, and with several co-authors. If you want to find out more about our views on woodlands in the UK context. Thank you.
Okay, so just whilst we wait for our next speaker to upload her presentation. So our next speaker is Mariam Pfeiffer from Newcastle University, and we're moving now from considering trees and forests to thinking about climate mitigation in agricultural landscapes. So over to you, Mariam.
Thank you, David. Can you hear me?
Yes.
Okay, great to be here. I'm an associate professor in landscape ecology and management at Newcastle University. And with my team and a lot of partners, especially in tropical countries, we are looking to identify nature-based solutions that can be used for climate change mitigation and adaptation in rural landscapes. And lots of them are crop production landscapes. So these rural landscapes, they are not empty. Crop production landscapes are not empty. They support biodiversity. They support people and their needs for clean air, high soil quality, but also they support crop production. And these crop production systems or farming systems, they can differ a lot. They can range from smallholder farmers. Similar in the UK, they will exist with limited mechanized inputs and no irrigation, to highly industrialized agriculture with high inputs of agrochemicals and irrigation systems and other mechanized measures. And I would like to point out that these farming systems, because of the way they are managed, their different management can have impacts. They have different biodiversity that they can support and different environmental impacts. So here in a landscape where I do a lot of work in Tanzania, where we have smallholder farmers and industry farmers, we can find a lot of exciting wildlife still in crop production landscapes if they are intermixed with a range of trees. So you are more likely to find lots of biodiversity on the systems that are more managed like agroforestry systems. And that is also smaller biodiversity that might be relevant for crop production, whether that is pests or pollinators or pest control species. Now, what I would like to point out here is that in the last couple of years, perhaps more than a decade or something, focus on farming systems has intensified. This is because they can be and they have been found to contribute to extensive biodiversity loss and carbon emissions. But because they cover so much area, as you've just seen in David's talk, they have to be solutions to the challenge. And in our research, we are trying to find out what that might be. And here I put that figure here in. That is not mine. That's taken from the paper by Xie et al. Published in 2018. That shows what these systems can look like. On the left-hand side, you have the forest, but you can farm in very different ways, from home gardens to agroforestry systems that also differ, sometimes with livestock, sometimes without, to farming systems that you find more typically in the UK. And these systems, there is some research on them, can have different carbon stocks, whether that is in the soil or in the trees. And the carbon stocks will differ depending on how many trees, what type of trees, whether there is livestock or not, or whether there is pastoral, like livestock grazing within them or not. And I would also like to point out again, because it's often forgotten, that we have to be clear about what we mean with climate change mitigation and adaptation. These two often and should come together, and they often do come together, but not always. So climate change mitigation is all about reducing emissions and stabilizing the levels of heat-trapping greenhouse gases in the atmosphere. And the first thing we should always do, and David already, you mentioned that, in your first talk is about reducing deforestation and forest degradation, so reduce the sources. And then the second part, and this is where ROOF comes into play, and also other research groups, is, well, planting trees, right? It has to be well planned. That was pointed out by several speakers, has to consider trade-offs. And I highlight that here again because it often doesn't come across very well. It is outcomes that we need to consider for food security, because we have to meet food needs as well, biodiversity and human well-being. And then climate change adaptation is sometimes the forgotten sister there, or brother, I don't know how to say that in England, but it's basically about adapting to the climate change that's coming. So we have already committed to climate change. That's unavoidable, and we have to prepare for it. And that can be through nature-based solutions. We can do that. Classic ones are flood defenders, improved water storage and use. But there's also, from trees, you get microclimate buffering, and you get soil erosion control, which is particularly important in tropical rural crop production landscapes. Look at these solutions that you can implement on the farms, you have to start thinking about where do you plant them, where do you put the trees on and around the farms, if at all, and so that they can provide benefits, whilst being aware that there might also be costs. And the benefits, we have talked about this, like water regulation, that is true, prevention of soil erosion, microclimate buffering, the species that provide services to the crops themselves, soil fertility. And then what's often forgotten is that if you have more natural habitats, especially in the tropics, you might get more pests, and you might get more elephants, for example, which are crop raiders. In the UK, that might be more like deer or other species like that. You can have disease spillover. There might be shade that farmers might be very unhappy about in competition with fruits. That will differ depending on crop type, so you have to look at that context specific for each landscape. And obviously you have less land for your crops. So can we have it all? Ecological benefits, well-being benefits, climate change mitigation and whatnot? I would argue probably not. So we have to accept, yes, there will be trade-offs. And then we have to make decisions. And then it's up that we have to also think about who is allowed to make decisions on the land that they own. And that is true for the UK as well as in tropical landscapes. And with that, I finish. Leaving that slide up for a short moment.
Okay, thank you very much, Marion. And then finally, for our panel, I'm going to turn to my colleague here at the University of Aberdeen, Neda Trifonova, and who is going to talk about the majority of the land of the world's surface area, which is in fact not land. So over to you, Neda.
Thank you, David. Just double checking, can you see my slides in presentation mode?
Yes, I can.
Okay, great, thank you. And hello, everyone. And moving on to the marine environment. So there's about to be an abrupt step change in the use of our coastal seas, and that is with the addition of these very large-scale offshore renewable developments that may take over 30% of our coastal seas. And given that, there will be many trade-offs to be weighed up rapidly for the future sustainable management and use of our oceans and seas. And that is, there will be benefits and trade-offs across the different marine uses. So for example, things like where would fisheries operate, marine protected areas, the extent of marine protected areas, but also, for example, shipping and navigation routes. So ecosystems are very complex, and we really, to be able to provide any useful management advice, we really need a much better understanding of the different mechanisms across these different habitats and their associated ecosystems. And to do that, we use these we want to use even more and utilize these ecosystem approaches, which bring the environment together, not only physical changes, biological changes, but the human systems as well. And ecosystems are complex, and relationships rise and fall throughout different time. For example, in some habitats, I hope you can see my mouse here on the left-hand side of this image. In some habitats, important things are species interactions or relationships with the environment, but also with anthropogenic stressors such as fisheries exploitation. But these are very much different across the different habitats and their associated ecosystems. And these things change with the addition of new anthropogenic transformation, such as the offshore renewable developments, but also climate change as well. So climate change and renewables affect, not all, they will have ecosystem level effects effects. There will be changes on the physical environment, the primary production that really will have knock-on effects on the entire ecosystem level, and changing different trophic levels, not only abundance and distribution, for example, the high trophic species, but also changes in abundance. And so really this is very complicated, and really trying to learn a little bit more by applying these ecosystem approaches. But what we're still really missing is being able to understand how these physical and biological changes are linked to the human systems, and they need to be considered in this as a whole ecosystem, and specifically how changes in the marine environment can actually influence ecosystem services, natural capital, and impact really the socioeconomics of different local communities. So what to do to address some of these changes? What we can do is collect better data in terms of being able to collect data across the physical environment, but also across different trophic levels. So what's been done so far is just focusing on different iconic species, for example, seabirds and mammals, and just focusing on them, rather than consider different species and different linkages together in this ecosystem combination approach. So what we really need to use is not only utilize different modeling approaches and existing data sources, but also apply some of these technological aspects, such as gliders and smart buoys and moorings, and upward faceless platforms with acoustics that can actually simultaneously collect information of the physical environment, but also the biology as well. And another thing to address, again, some of these challenges of bringing the physical and biological ecosystem and human system is really a full utilization of these ecosystem level approaches, where we can bring together up and downstream interactions and relationships to really understand what is going in the environment, what is going to change, what are the most sensitive species and habitats, and what are the habitats and species that are more resilient to risk, and how things are going to change in the future, again, and with respect to climate, but also anthropogenic transformations. But this will also give us an indication what are the benefits and the trade-offs between the different users and industry, to really be able to understand and use our marine resources sustainably, and to be able to translate what we're hoping to do is with this ecosystem level approaches is really to translate the outputs of these approaches into natural capital approaches, so that we can actually have a full understanding of ecosystem service, being able to evaluate provide a socioeconomic valuation of different ecosystem services, not only fisheries, but different provisioning services, and be able to fully address nature-based solutions in the marine environment. So that's me. Thank you.
Thank you very much, Neda, and to all of our speakers this morning. So now we have just over 15 minutes left for question and answers, and there are some questions that have come in. Oh, sorry, turn on my camera. So first of all, I want to just target a few to Ruth, who seems to have attracted talk has attracted quite a lot of interest. It's not understandably, given the local context. So first of all, Ruth, interesting results from Balogi. Is it clear why so much carbon is lost from the soil when switching from heather to trees? Is it just soil disturbance from planting? So that's one question. And whilst we're with you, there's also an interest in, do you know of any other kinds of plants which might be better at carbon storage, and would planting more trees at the individual level, for example, farms or gardens, make any difference at all?
Yeah, so the first one about carbon store, why we're losing the carbon, we actually had very minimal soil disturbance when we planted our trees. So we literally just slot planted them with a spade and put bare rooted trees in. So we don't think that our carbon losses are actually due to the amount of soil disturbance that went on. But what seems to happen is there's a change in the soil microbial community as the trees establish. So you may know that a lot of plants have what we call a mycorrhizae association with fungi, and the fungi help them sort of gather nutrients and things. But it's a different type of fungi that are associated with the pine and the birch trees than are associated with the heather moorland and the heather. And we think this switch in some of the fungal communities, the type of fungi that are associated with the birch and the pine, they've got enzymes that are capable of actually breaking down that carbon that's locked in the soil. So it's this change in the microbial community that is possibly driving some of these changes. But we do still need to do a bit more research on that. But that's what we think is happening. There's changes in the soil microbial communities driving it. So I hope that answers your first question. Your second one was around
different species.
Different species of plants.
Yeah.
I think it's not just the species we need to think about, but it's also really being aware that we need to think about what's happening below ground as well. So whatever land use we have above ground in terms of crops or trees, we need to think about what's that impact having on the below ground soil. Because I said earlier, globally, much more carbon stored in the soil. So we also need to think about how our land management is impacting the soil and how we can increase the amount of carbon we're storing in the soil, as well as in our above ground vegetation. But specifically with respect to plants, obviously peatlands and sphagnum mosses are the obvious other one to talk about in terms of how we can store more carbon. But again, that's why we're doing a lot of restoration at the moment in Scotland, to try and restore a lot of our peatlands, is because of their potential to store carbon.
Okay. Yeah, Pete, over to you.
Yeah, on the peatlands point, a degraded peatland can be emitting up to over 30 tonnes of CO2 equivalents per year per hectare. So that's 100 by 100 metres of peatland emits more carbon dioxide than about 7 average family cars. So just by restoring those peatlands, we can switch off that carbon emission by re-wetting them. It's the fact that they're drained that allows the CO2 to be oxidized and emitted to the atmosphere. So by re-wetting them, you can more or less immediately switch off that large emission, even if it takes a few decades for them to be restored to their former glory and to start sucking up carbon again. You get an immediate benefit of switching off that huge emission. So it's a real big win for Scotland, and in the UK actually, it's a real big win for the UK, a nature-based solution that we don't hear enough about, and that can play a really significant role in us meeting their zero targets.
Thank you. I mean, staying on the theme of tree planting, it seems as this is a question that has attracted a lot of interest. Is on a commercial scale, how can we reduce ground disturbance when planting trees? So the conventional approach of manding or ploughing allows weed-free sites, which is obviously advantageous for young seedlings and reduce the need for weed killers. Has there been any research done? Now, I'm not sure whether we have any sort of forestry specialists on the panel who could address actual practical approaches to tree planting that would minimize soil disturbance, but also allow weed-free microsites. Ruth, is that anything you know about?
I can give it a go.
Okay.
I know forest researchers are doing more on this, so it's not an area I'm expert in. And I think part of it depends on the soil. So if you can do some of these more disturbance techniques on more mineral soils, because then you won't be at risk of losing so much carbon. So some of the issue is what type of soil do you plant the trees on? And if you target the soil type correctly, that will be less of an issue. But yeah, I'm not sure there is a real solution to what you do on the organic soils, because if you disturb them, you will release carbon. And as I was trying to say in my earlier answer, even with minimal disturbance, we're still seeing this loss of carbon. So it's not part of the issue is soil disturbance, but that's not the whole story. There is other biological mechanisms that are driving that loss of carbon associated with the change to tree species.
And do you think here that this is an area where, you know, in principle, we could be relying more on natural regeneration? So, David, you referred to that trade-off between between tree planting and just allowing more passive methods of tree colonization on sites, in which case there would be no need for ground preparation. I mean, it's obviously may not be optimal from a commercial perspective, but it's even on on the right kinds of soils, as Ruth has emphasised, that might be the preferable approach.
Yes, indeed, yeah, and we won't get the rapid initial carbon drawdown which we would from planting, but over time the evidence is that natural colonisation starts to ramp up its carbon sink over time, and after 70 years it's fairly indistinguishable from planted woodlands, and we would imagine that natural colonisation just wouldn't go into the wet peatlands because trees would struggle to grow there. So that I think if you're wanting to plant peatlands up, and there's plenty of good reasons not to do that, it's really hard to do that without drainage, because plants need oxygen to get through into their roots for respiration. So yeah, if you want to plant peatlands up, and I personally don't, and I think there's very good reasons from a climate perspective that we should be avoiding the peatlands, but if you did, then you have to drain them, so that's where the difficulty is. Yeah.
Okay, here's a more general question, and actually one that's possibly relevant to anybody, all panel members, and that's the issue around sort of carbon offsets. Is there a need for an authority that could ensure that monies contributed for carbon mitigation, for example by airline passengers, are used in a way that ensures genuine reduction of carbon?
Pete first, I'll have a go as well.
Okay, David.
No, Pete first, go on.
Well, I was going to say that there are two markets for carbon that's sold in this way. There's the compliance markets, which are regulated by governments, and it's things like the EU emissions trading scheme, which is sort of like an intergovernmental exchange of carbon credits. That's quite well regulated. And there's a voluntary carbon market, which is less well regulated, and it's that is sort of seen as the Wild West. That sort of there aren't really too many regulations. There are some great projects out there that are really well regulated and really well monitored and verified, but you often hear some sort of like some bad stories about some projects that are being protected, and the main ones are, for example, when there was a forest that was never under any threat of being chopped down, that carbon credits are being spent to support that forest, those forests. There are some in South America that have received millions of dollars of carbon financing, but that's not going to really deliver any benefit to the carbon, because there's no additionality. It's called additionality. So there's no additional carbon that's being stored through those projects, because those forests were protected and weren't going to be chopped down anyway. So there are those sorts of issues to do with monitoring and verification, to do with the additionality, and there's another one called leakage, which is if you do something in one place and you cause emissions in another place, that's known as leakage, and ensuring that there's no leakage is another big need. So I don't think it's possible to have a central organisation that covers that, but there certainly needs to be better regulation and governance of the voluntary carbon market.
And just following up on that, so the example I gave of open dry woodlands in southern Africa, if you protected the forest in one site to protect the charcoal there, but there wasn't an alternative use for an alternative energy supply in the towns, then people would just go elsewhere to harvest wood for charcoal. You haven't resolved the problem. You've just shifted it elsewhere. So that's the sort of dilemma. But there are several projects and companies starting up to try and create trustworthy carbon credit markets. And I'm actually involved in one myself, but there's several building up at the moment.
Okay, thank you, David and Pete. And Marion.
Yes, I would like just to point out it's not just the reporting or the what do you compare it against in terms of baselines, and it's not just about, like, you know, what David talked about. It's also about how's the money that you're raising, may say it comes from industrialized countries, how it's distributed and arriving at the communities that have to live with reforestation targets imposed often onto them through these carbon credit schemes. It's a very interesting and certainly challenging pathway to tread. And I do point out that what you want to meet is not just your carbon. You know, we are doing the carbon emissions, and then we're paying someone else that's not our land to do the carbon storage is not quite fair, and we have to compensate. And that compensation is not just payment for the trees, it's you have to monitor and account for biodiversity outcomes and well-being outcomes. And the well-being outcomes are very complex things and very difficult to monitor and ensure that there's properly safeguarding for these communities. So I just put that in here because it's often forgotten.
And Marion, can I just quickly follow up there? And those are all really good points. And I'm wondering whether they are whether those are issues that are directly identified by the Tanzanian communities that you work with.
Yes, partly there. It's very, very obvious. Like they have very different priorities, but also even if you speak to governments, on the one hand side, they are committing to climate change mitigation targets like planting trees. On the other side, they are having agricultural policies where they say agriculture comes first. These two cannot be reconciled easily. There will have to be trade-offs, and these trade-offs and the decisions on them have to be decided. Well, it's up to different people have different opinions. I personally believe it has to be bottom-up driven, but you know, it's difficult to reconcile with carbon payments and these markets, whether they are voluntary or whatever mechanisms you use. And there's good evidence that they don't work very well, and there's no or very limited evidence that they have worked anywhere in the topics.
Okay, thank you very much. So I just want to turn to something that David touched on in relation to sort of more urban environments. So has there been any research done into the potential benefits of small-scale tree planting across residential gardens, private land? I think the answer to that is yes. Many of the major UK city councils will have very detailed inventories of their treescapes or their urban treescapes, and that's certainly true in Aberdeen. It's also true, I'm aware, in Belfast. So quite detailed maps down to individual trees of what's there, and then you can take that data and use it. So yeah, over to Pete and Ruth, I think, and David also have got a response to that.
Yeah, just to say that the Welsh Government is going to be giving a tree away to every citizen of Wales. So that's something the government can do. In my own home, we've planted more trees in our garden just because it's a nice thing to do. We get a lot more birds in. That wasn't done for carbon sequestration. That's a benefit. So individual nature-based solutions, if you're lucky enough to have a garden, is a great way to go.
Yeah. Ruth?
Yeah, just following on from Pete, really, just to say certainly in urban situations, there are many more advantages to planting trees than just carbon sequestration. All the biodiversity benefits. There's evidence about heat cooling effects in terms of cooling the temperature for urban environments, removing pollution. So, you know, a lot of other benefits as well that we get from these sort of smaller trees in our streets and our parks and our gardens.
David?
Just to add that, I was contacted recently by somebody because the county council was going to remove trees because of substance problems around with houses, and they were up in arms about it. And it transpires that the Woodland Trust has got a large unit working in cities, thinking about cities and trees. So that some of the big charities are really actively involved in urban trees as well.
Okay, so we've got 1 minute left, and I'm just going to go around the panel with this final question and see if we can get one quick comment from everybody. At an individual level, apart from eating less meat, how can we help? So I'll go last, so that'll be the toughest job. And would anyone like to go first? Pete?
Yeah, I'd say fly less, use active transport whenever you can for your own personal mobility, and get involved with local projects because there are local charities that are doing planting up and restoring certain areas. Get involved with those local projects. There's a lot you can do. Yeah,
David, next.
I'm going to completely agree with Pete. So there we go. Next.
Pete's used up all the ideas. Anyone else? Ruth?
Well, yeah, certainly agreeing with Pete in terms of travel less, but I think lockdowns have made us appreciate our local environment more, and you know, encourage people to stay local and explore their local environment for getting out and for holidays and things. There's a lot we can do locally.
Definitely. Okay, do Marion or David, you got another idea?
Like, can I just add to that talking with Woodland Trust again, their worry is the people in urban areas, and I'm in good fortune living in the countryside, and how we make nature accessible to people in urban areas. That's something we do need to think about if we're really going to crack this problem.
Yeah.
But I will add something to it. So the treescapes project have been launched, right? There's a lot of interesting projects currently underway to do exactly what David was proposing. I'd say use less cars and get especially parents of school-age children to use more bicycle or walks, because that seems to be a huge problem here. And yes, you know, local, I agree with Ruth on the holiday thing, but I personally cannot cope with the UK weather, and I totally understand if people feel the need to go to France for their holidays. I would never criticize anyone for that.
Neda, do you want to come in?
Yes, yeah, thank you. Yeah, I agree with all the points, but I think also it's quite important to reach out to your community and your colleagues and friends, and I think just talk about the things that people can do on an individual basis, because not everyone is aware. And simple things, yeah, like planting trees in your garden, you know, cycling to work, you know, these things make a difference, and it is important what we can do on an individual basis. So I think, yes, also adding up, yeah, talking to your colleagues and get involved more in local projects.
Yep, and finally, then I will support all of the ideas, and in particular the one around supporting local projects. And if you're an Aberdeen City resident, and you have the wonderful Aberdeen City Green Space project, and very well supported by our local council. Depending on where you live in the city, you may or may not have access to more or less of that, but it's we're very well served here locally. So I'm going to close it there. We're just slightly after 12. I hope you've enjoyed the session. Thank you very much for all the posted questions, and a big thank you to our 5 speakers, both internally and externally. It's been a very useful and informative discussion, and so I'll close it there with those thanks from me personally, and say goodbye to everybody.